Section 7.5, rational exponents and radicals. All right, so the entire idea today is figuring out how to turn a radical expression into a rational exponent and then vice versa. So that means taking like the square root of 27 and then writing it as an exponent of 27 to some power. And that's what we're talking about today. So the first thing we need to do is define the term index. And so in this case, the index is the small number to the left of the radical symbol that tells you which root to take. All right, so if you've got, this is called the cube root. Your normal square root looks like that, but they don't write a number out here. If there's no number written, assume it's a 2. There's the fourth root, and then so on. And these can be a variety of different ideas. And so this first key concept at the bottom talks about how do you transform an exponent expression or an exponential expression like this into a radical expression. Well, to do that, you're going to take the bottom part of the exponent fraction, if it is a fraction, and it's going to go right here as the index. The top number, however, is then going to be the power of whatever goes underneath your radical. So in this case, underneath our radical should be the a, and then it's going to be to the 1 power. So let's do an example real quick before we start the note. So let's say I gave you 7 to the 2/3 power like this. Remember, this is where we're going to take, we've got the square root symbol, or we got the root symbol. Your index in this case is 3, so the 3 is going to go here. The 7 goes underneath, and then it's raised to the 2nd power. All right, and so that's ideally all we're doing. So here are our first 3 examples, and we want to write these as exponents, and then we can simplify from there. So keep in mind our index here is 3. So in this case, when I say index, I'm thinking back to our original statement where it was a to the m over n equals the n power a to the mth. So that's what we're kind of doing here. So now this 3 represents the n. So I know that when I set this up, it's going to be 125. M in this case would be the 1 that's on the 125, so 1 to the 3rd power. This expression can be put into our calculator to simplify. So you have 125, you use the up caret symbol, and then you're going to put 1/3 as your exponent, and then your final answer then becomes 5. Second problem, same idea. This would be n. Our m value is going to be 1 there, so we're going to write this 16 to the 1/4 power. Same thing, put this in your calculator. You're going to get 16 to the 1/4 power is just 2. And then here, your m is 1, your n is 3, so 64 to the 1/3 power. Once again, put this in your calculator, and you're going to get 4. So now we're going to go from taking an exponential formed problem and convert it into radical form. So same idea. To keep in mind here, we talked about the conversion rate. So a to the m over n is going to be equal to the nth root of a to the m power. So what we want to do in the first problem is recognize that the 5 here is m, the 6 is n, and this is just our base. So if we start pulling things out where they need to go, it's going to be the 6 is our index, a to the 5th power. Question 2, same idea. M is 1, n is 4. So we've got the 4th root of x to the 1st power. Question 3 is a little different. Remember, the exponent only applies to the thing it's touching, so we want to worry about the y to the 2/3 power first. So we've got m on top, n on bottom. So if we just write this as a radical, we'll have 3 square root of y to the 2nd. The question is, what happens to this 8? It's not impacted by this particular exponent, so in reality, all we're going to do is throw it on the outside. And so these are our answers. Let's keep practicing this idea. All right, very similar to the last problem, we're looking at question 4 here, where the b is the only thing with an exponent. So right off the bat, I know the 7 is going to stay, but I know that this is my n, or my index, and this is my m. So that means I have the 4th root of b to the 3rd. This time, however, notice the parentheses, meaning that this exponent is applied to all of this. So this is my m, this is my n. I can now go ahead and simplify this. It's the index of 3, square root, or root symbol, the root symbol, and then we're going to put 8, y, and then we're going to go ahead and put the squaring here. And this is your answer. The only thing we've really done is move the index in order to make this a part of a radical statement. And then last but not least, we've got this last one here. Once again, it's in parentheses. We've got m over n. So with this, we've got 5, root symbol, 64y to the 4th power. So the last 6 problems, we want to take a look at how we go from radical form to exponent form. So kind of the other direction here. So in the first problem, we've got the 5th root of b to the 3rd. So keep in mind that this would be n, this is our m value, and we know that in order to create, if we start with this, it's going to become this. So we go from radical to exponent. So keep this in mind as we work through these. So let's create our radical forms. So we know that our base is going to be b, 3rd power on top, index of 5 on the bottom. So this is your answer. Question 2, same idea. We've got n, we've got m. So y, 4th power on top, index on bottom, 7. So 4/7. Here we've got 2 different bases, but the same rules apply. We've got n, and we've got an m and another m. They vary by the bases they're attached to. So we're going to go ahead and create this the best we can. So here we've got m to the 4 over 4 power, n to the 20 over 4 power. And we can simplify this. 4 over 4 means m to the 1st. 20 divided by 4 is n to the 5th. So this is our answer. So really, we're just doing the opposite of what we were doing before. We're kind of going backwards and forwards. This is all about just converting from exponential to radical and radical back to exponential. That's all. All right, one more set. Here, we're going to get a little trickier. Now we have to include some coefficients underneath the radical, but it doesn't change much. So same rules apply. If we're going from radical form to exponential, the same rules apply. We know that this is going to be n. This is the m for the d, but the 27 also has its own m value. It's 1. So as we go to set this up, what we're looking at here is 27 to the 1/3 power, d to the 5/3 power. What we can do here is we can simplify this piece by putting it in the calculator. 27 to the 1/3 power should be 3. And so we've got d to the 5/3 power. So 3d to the 5/3 power. Then question 5, same idea. Your n value is 5. The 32 has a 1. And this is your m for the c value. So we've got 32 to the 1/5 power, c to the 10/5. Then we just need to simplify. Calculator-wise, 32 to the 1/5 power is just 2. And then 10 divided by 5 would be 2. So your final simplified answer would be 2c to the 5th, or 2c to the 2nd. I almost said 2c to the 5th. That would be wrong. It's 2c to the 2nd. There we go. And then the last one, same idea. We've got our n value is 4. 81 has an m value of 1. Then the x has an m value of 2. So you've got 81 to the 1/4 power, x to the 2/4 power. So now as we simplify this, because we can put this in our calculator and figure out what this is, this should be 3, and this would be x to the 1/2 power. And there's our answer.